Now, on the next page, on the next section, I want to start talking about 402 right now. And in 4.02, there are two different major systems of logarithms in use today. We have what we call common logs. Common logs, those are logarithm base 10. All right, this would be base 10. And we have something called natural logs. Natural logs, which would be log base E. Whatever in the world E is, which we will get to momentarily. All right, so there are those two main systems. On your calculator, the logarithm base 10 will be designated like this, log. And right above it is the inverse function for the log button, which is 10 to the x power. The natural logs are represented with the button ln. And right above that would be the inverse function for that, which would be e to the x. Do you see those buttons on your calculator? Yes.
Yeah, just going back to what you did just a minute ago.
Okay.
About the log, you typed in log 10. I'm sorry, log 0.1.
Log 0.01.
Okay, well now you have log 10 to the x equals 0. If you type in log 0,
okay, what was the problem?
Number 7.
Number 70?
On page 9, in other words.
On page 9.
How do you work to the 0?
Okay.
The 0 messes it all up.
No. Now, number 70, all right, the question was asked of number 70. Let me stop for just a minute to answer that one. Number 70, it says log base 10 of x equals 0. Log base 10 of x equals 0. I'm not asking for the log of 0. I'm asking for the log of what will give you 0. So we have to translate first. See, what does this say? Translate it back to exponential form. 10 to the 0 equals to x. Now 10 to the 0, what's 10 to the 0? 1. 10 to the 0 is 1. All right, now I want to follow that up with this thought. X is 1. Okay? Now calculate the log of 1, base 10. Use your calculator. And what do you get?
0.
0. Okay? So in other words, the log base 10 of 1 is 0. Did you get that? You give your calculator 1, and then hit the log button. Give your calculator a 1, and then hit the log button. And what do you get?
0.
You get 0. All right. Now, give your calculator 0, and ask it to take the log of 0.
Error.
Error. Your calculator can't take the log of 0, can it? Your calculator cannot take the log of 0. So we won't be asking it to for a while until you understand this. And then this is a very important concept that you'll understand later. You probably don't understand it right now, but later that will be more apparent to you. Okay, so in other words, we weren't taking the log of 0. We were taking the log of what equals to 0. Okay? All right, now back to the calculators here. I just want to do a quick summary of a couple of things here. Let's do the log base 10 of 1,000. I want to do the log of 1,000. Log of 1,000. In other words, you just enter the 1,000 and hit log button, or if you've got a graphics calculator, you're probably going to have to go log of 1,000. And you get what? 3. Everybody get that? Give the log of 1,000,000. The log of 1,000,000, what do you get? 6. Does everybody get 6? Okay. Well, that's easy, isn't it? How about giving it log of 0.00001? Now, what have I got there? 1, 2, 3, 4 zeros?
-5.
You're going to get -5? Okay. Any questions on that? Y'all seem to be finding logarithms all right. Let's do one more that doesn't come out even like that. Let's do the log of 375. Log of 375. And what do you get for the log of 375?
2.57.
Okay, what is it?
57.
2.57.
4, 0,
4, 0, it goes on and on and on, doesn't it? It doesn't come out even, right? That's good enough. We'll just call it 2.57 for right now. Round it off to the nearest hundredth, I suppose, would be an acceptable way to handle this. Okay. Now, what would happen? There was a concept I need to do here. What would happen if I did the, give your calculator a 3. Give your calculator a 3, and then I want you to do 10 to the 3 power. Now, if you've got a graphics calculator, do this first. Do the, in order to get into the 10 to the x power, it's off of the main button, isn't it? So to get that, to access that, you're going to have to hit the shift button, or maybe it's second function button, or maybe it's inverse button. You've got a button up here on the top left-hand side of the calculator. Give your calculator, if you've got a regular calculator, give it a 3, and then do shift log. If you have a graphics calculator, do the shift log first, and then give it a 3, and execute.
Are we looking for log or log at 10x?
10 to the x, that's it.
Right. So that'd be the second.
That'd be the second function, shift. Right. And what did you get?
1,000.
1,000. Did everybody get 1,000?
Yes.
All right. With the regular calculators, the non-graphics calculators, you're going to enter the 3 first, and then do the shift log button, and you're going to get 1,000. Now what I want you to do, you got 1,000 still in your calculator?
Yeah.
Now hit that log button again. Now for those of you who have the graphics calculators, this is going to be a little bit harder for you. You're going to have to go shift, you're going to have to go 10, you're going to have to do log of shift log 10. Do log of shift log 10. And guess what's going to come back?
Scenario.
I'm sorry, log of shift log 3. Log of shift log 3. You're going to come back to 3, right? What I want you to see is that these buttons, this shift log, this 10 to the power of x, and the log button are inverse functions. They undo one another. They're like the wrapping and the unwrapping of presents. You know, if you have someone that you love and you give them a present, what do? You wrap the present, and then what do? They unwrap it. All right, so here, log and 10 to the x are inverse functions of one another. They're going to undo each other. So let's start with 375. Those of you that have regular calculators, you're going to do it this way. You're going to take 375, and you're going to take log of 375 first. Do log of 375.
2.57.
And you get the 2.57 number. Now, if you've got that number in your calculator, then do shift log of that number. And guess what comes back? 275. 375. Okay? Any questions on that? If you have a graphics calculator, what you would do, you would do the shift log of the log of 375. And you end up with the 375, don't you? You see what this is doing? This is undoing itself. All right. Now let's talk about the E and the ln function again. Not again. This is the first time. All right. Let's let put a 3 in your calculator. Put a 3 in your calculator and hit the ln button. And what you're going to get is the ln of 3. In other words, I want the ln of 3. Those of you with graphics calculators, you're going to have to hit the ln button first, and then the 3. And what do you get? 1.09 something 8. Okay? All right? Now, what would it take to undo that? E to that. Okay? Shift ln of that number. If you've already got that number in your calculator, then what we'll do shift ln of that, and guess what happens? Does it come back to 3? It does, doesn't it? See? So that's an important concept, that the e to the x and the ln are inverse functions of each other. All right? Now, I want to calculate the value of e. We've been talking about e to the x all this time, and I've never bothered to figure out what is e. What is e? What we have to do to get e to a power is we start off with 1. If you want e to a power, give the calculator a 1. If you have a graphics calculator, hang on just a minute. Oh, you already know how to do it. All right, great.
Wait a minute. A to the what?
You already say, you do that again.
Okay. First of all, give the calculator a 1. Give the calculator a 1. And then do shift ln. Second function ln.
E to the x.
And that's it, e to the x. And then what do you get? 2.71
8.
28. I'm going to carry this one out.
1828.
1828. That's good enough?
It
Okay.
does it again.
It does it again, a 1828?
Yeah.
But by the way, it's not repeating a pattern, it just looks like it is. It doesn't continue in that pattern.
Does it continue
Right.
at 1828?
It doesn't continue to repeat any pattern, because this is what we call an irrational number. It never comes out even. It's the base of our special logarithm system, and it's called the natural logarithm system because this logarithm system has some very special natural properties that we'll get into later. Not today, but we'll get into that later. All right, so now, that's the value of e. That's your calculator value of e. There's a place you might want to write that down. On page 11 of your work, there's a place for you to write, my calculator value of e is, that's your calculator value of e. All right, now I'd like to do a couple, let me summarize what you can now do. Do you know how to calculate 10 to the 375 power? Oh, no, I'm not ready to summarize yet. Let's do some more e to the power. I want to do e to the second power. If you got that number in your calculator right now, how would you get e to the second power? There are 2 ways. One way is to just hit your x squared button and square it, right? Because e is that, and e squared would be the square of that. You could do it by squaring the number. What do you get? 7.38, 905, something like that. Okay, good enough? All right. Now let's do it another way. Give your calculator a 2, and then do the shift ln. E to the 2 in that way. Do shift, give the calculator a 2, and then do shift ln. Those of you with graphics calculators, you're going to be entering the shift ln and then 2, and then execute. And you get the same thing, don't you? I hope. 7.3890, whatever. Okay. Any questions on that? Okay. Now I think we figure that. Okay. Well, what if you wanted e to the negative 2? What if you wanted e to the negative 2? Can you get that?
Yeah, shift ln.
By the way, if you already have e to the 2 in the calculator, if you already still have that in the calculator, how can you get e to the negative 2? That's just 1 over it, isn't it? Do you have a 1 over x button on your calculator? Push the 1 over x button, and that'll give you the answer. Take the answer for e to the 2 and push 1 over x.
Oh, there it is.
You got a 1 over x button on your calculator? That'll get you the reciprocal. That's called the reciprocal function. Anytime you want 1 over, you can push that button and it'll give it to you.
Doesn't just keep one.
0.1353.
0.135, that sounds good. Something. Now, do it the regular way. All right, erase the calculators. Let's start over. Now, do e to the negative 2 by starting out by giving it the negative 2. Now, you may have to give it 2 first and then hit the plus or minus key.
Second.
And then second function, ln. Does it give you the same number you had before?
Yeah.
I hope. Yes, it does. Okay.
Why is it 1 over negative 2? I mean,
Because e to the negative 2 means what? 1 over
E to the second.
e to the second. E to the negative 2 means 1 over e to the second. See, so you learn to use a few extra buttons on your calculator. That's helpful. All right, let me summarize it this way, and then we'll take a break. I want to summarize it this way. Do you know how to take the log of 375? Do you know how to take ln of 375? What's the log of 375? Log means log base 10.
Like 2.5.
It would be 2.5657.
no, 5.7.
570.
5.70. I mean, 5.74.
You can stop
And
there.
that's good enough, okay? What would be the ln of 375?
5.92.
How much is it?
92 or 90.
5.926. We rounded off to 5.93. Okay, that's good. Now, what if we wanted to take 10 to the 3.75 power? What if you wanted to take 10 to a power? Do you have an idea how you could do 10 to a power?
Wow.
You got a 10 to the x function right there. That inverse of the log is in other words, give the calculator 3.75 and then do shift log, which is 10 to the x, isn't it? And what would that be?
Shift log.
Yeah, shift log, second
Yeah.
function log.
5623.41.
Did you get a number? What is it?
56.
56. I think it's going to be more than that. It's going to be...
56.23.
Oh, okay, you're giving me the numbers. 55, 6,
23.
23.41. Okay. Do you see that 10 to the third power would be 1,000? And 10 to the fourth power would be 10,000, right? So 10 to the 3.75 power would be somewhere between there, wouldn't it? That's how I knew it wasn't 562. I knew it had to be so many thousand. Okay? All right? So that's how you can calculate. That's a quick way to calculate 10 raised to any power, any decimal power, just by using that. All right, now what if I wanted to calculate e to the 3.75 power? How do I calculate e to the 3.75 power?
42.52.
Shift ln, what's the answer? 45, 40,
42. 5210.
5210. We'll just call it 42.52.
Right.
Okay? Any question on that? That's how we get e to a power. All right, now, quickly, without going to a lot of trouble, can you tell me what would be the ln of e to the 3.75 power? What if I ask you to do e to the 3.75 power and then take the ln of it?
3.75.
And you end up with 3.75, don't you? Is that amazing or what? 3.75. Did you have to calculate that to know it?
Yes.
Not really. Think about this. What does ln do to e to the power? What do these two buttons do to each other? They're inverses of each other. In other words, if you take the ln of e to the power, you get the power. The generalization of this is like this. ln of e to the x power equals to what? ln of e to the x would be x. ln of e to the x would be x. Okay? Any questions on that? All right. I think that's probably a good summary of how to use the calculator. I'm running overtime, so I think I'll stop and give everybody a chance to take a break and for about 5. In the first session that we just had, I was corrected on a couple of things. I may have said that e to the x and ln of x are reciprocal functions. They are inverse functions. They are not reciprocal functions. And 10 to the x and log base 10 of x, these are inverse functions of one another. They are not reciprocal. If I use the word reciprocal of the reciprocal of x would be 1 over x. And the reciprocal of e to the x, the reciprocal of e to the x would be 1 over e to the x. I think that's what I was talking about, the word reciprocal. We were talking about e to the, if I talked about e to the negative 2, that was 1 over e to the second. This is the reciprocal function. And that's the reciprocal function that I was talking about on the calculator. And I in no way meant that e to the x and ln of x are reciprocal functions. They are inverse functions of one another. Inverse function, remember if I said f minus 1 of f of x, these are inverse functions. What's an inverse function of f of x? What if we do f minus 1 of f of x? What's the effect of this f minus 1 on the f? It neutralizes it and it returns you with the value of just x. You see, it undoes the f, and that would give you x. Okay? Another deficiency that I realized I made in that last tape is that I didn't really explain what I meant by ln of x. ln of x means log base e of x. The ln of x means the log base e of x. And we call it ln because L stands for logarithm and N stands for Napier or natural. So we're talking about the natural logarithms or the Napier logarithms when we talk about the ln of x. That's very important to realize that ln of x means exactly the same as the log base e of x. Okay? In this next section, 4.03, I want to get into the properties of logarithms, which were laid down in section 2, but I didn't do it on this tape. They were kind of developed in the handout of section 4.02. Let me do 2 quick properties with you.